This video is about understanding and completing problems related to bisectors and trisectors of segments, finding the point or points that partition a segment into a given ratio, and understanding and completing problems related to bisectors and trisectors of angles. So, our first vocab word of the day is a midpoint. So, a midpoint is a point that bisects a segment into two congruent segments. So, if we had our segment WT, in the middle M, if this is going to bisect it and marks it incongruent, this would be our midpoint. Why can't lines and rays have a midpoint? Because they extend at least one direction infinitely. So remember, lines go in both directions forever, and rays go in one direction forever. So you can't find the midpoint of something if you're going somewhere forever. So in number one, line CL bisects RT. What can we conclude? Well, RT is a segment. So at this point, it's bisecting it. So it's going to cut it into two congruent parts. So we can conclude two things. One, we can say that RA is congruent to TA. And we can say A is the midpoint of RT. In number two, draw and label segment WT that bisects segment BD at S. So we know that segment BD is going to be bisected at S. So we're going to put S in the middle. We're going to put our tick marks. Then somehow we just need this another segment going through it with T and W. That is not necessarily bisected. So one part can be larger than the other on WT. In number three, U is the midpoint of segment CL. Once you see the word midpoint, make sure that you mark these pieces on our segment are congruent. Find UB and CB. So in order to find that, we first need to know what X is. So we know that they are split into two congruent parts or in half. So those have to be equal to each other. So we have negative X plus 20 is equal to X squared minus 2X. Because there's an x squared in the problem, that means we're going to factor. So we're going to move everything to the x squared side. So 0 equals x squared minus x minus 20. We need two numbers that multiply to negative 20 and add to negative 1. So we're going to have 0 equals x minus 5 and x plus 4. When we switch our signs, x is 5 and x is negative 4. So if we have x equals 5, when we substitute in to find UB, 5 squared minus 2 times 5 gets us 15. So UB is 15, which means CU, when we put in the 5, negative 5 plus 20 is also 15, which means that 5 is staying as a solution. So CB is the whole line, so we would double that to get the length of 30. Now with negative 4, usually our negatives don't always work, so we got to really make sure we double check. Negative times negative 4 plus 20 is positive, and negative 4 squared minus 2 times negative 4 is positive, so it stays. So if x equals negative 4, UB is going to equal negative 4 squared minus 2 times negative 4, which is 24. And when we double it, CB, then the whole line is going to equal 48. In number 4, C is the midpoint of AD. So this is going to be half of our line, and this is going to be half of our line because C is a midpoint. But it also says that B is a midpoint. So it's going to take this half here and split it into a fourth and a fourth. In the problem, we are given that AB is x plus 2 and AD is 5x minus 2. So if we have a fourth of a line and the whole line, we need 4 fourths to equal a whole. So we need 4 times the length of AB to equal AD. 4 times x plus 2 is equal to 5x minus 2. So we get 4x plus 8 is equal to 5x minus 2. As we solve, we get x is equal to 10. Once we know x is 10, we want to find BD. So BD is this whole segment here, which is 3/4 of the line. In order to find that, we can substitute 10 in. We get that AB is 12 and AD is 48. So to find BD, we can do 48 minus 12, which gets us 36. So we are going to skip number 5 and go down to our midpoint formula. So the midpoint formula is used to find the midpoint between two coordinates. The midpoint is the averages of the coordinates. So we're going to add the x coordinates, divide by 2, and add the y coordinates, divide by 2. So in number 6, find the midpoint between -1, 8 and -5, 4. So our x coordinates are going to be -1 plus -5, divide by 2. Our y coordinates are going to be 8 plus -4 divided by 2. So -1 plus -5 is -6, divided by 2 gets us -3 for the x coordinate. And then 8 plus -4 is 4, divided by 2 gets us 2 for the x coordinate. So moving from a bisector or midpoint to trisection points, these are points that divide a segment into 3 congruent parts. So in a trisection, we would have a large segment, so A and B, and then we'd have 2 points that are really dividing this line into thirds. So all of these pieces would be congruent. So AC would be congruent to CD, which would be congruent to DB. So in number 7, A and W are trisection points, which means each part of this line is going to be congruent. We know that HK, the whole segment, is 42, and AW is 6x plus 2. So 6x plus 2 is only representing a third of the line because of the trisection. So we need 3 times AW to equal our length of HK. So we would have 3 times 6x plus 2 is equal to 42. 18x plus 6 is equal to 42. When we subtract 6 from both sides, we get 18x equals 36. So when we divide, x is 2. Now, in number 8, we have to be careful. We know that CU is 2x plus 19, UB is 6x minus 9, and BS is 6x or is 5x minus 2. And this whole segment, CS, is 15x minus 6. Are U and B trisection points of CS, Y, or Y not? So right now, we don't know if they're trisection points. We're trying to investigate that. So for now, we're going to start by using segment addition. So when we use segment addition, we need to add all of our pieces up. So 2x plus 19 plus 6x minus 9 plus 5x minus 2 is equal to 15x minus 6. So when we combine our x's, 2, 6, and 5 gets us 13x, and we combine our constants, 19 minus 9 minus 2 gets us plus 8 is equal to 15x minus 6. So we can subtract the x's to one side and add the 6 to the other. So we have 14 is equal to 2x. And we divide x is 7. So to figure out if it's a trisection point, each of these 3 sections needs to have the same length. So we can investigate. 2 times 7 plus 19 is 33. 6 times 7 minus 9 is 33. And 5 times 7 minus 2 is 33. So in this case, because all of them are equal, that means that U and B are trisections. So yes, U and B are trisection points because CS is divided into 3 congruent segments since they have the same length. Number 9, EH is divided by F and G in a ratio of 5, 3, and 2 from left to right. If EH is 30, find FG and name the midpoint of EG. So, in a ratio, remember that they are all reduced by a multiple. So, we have E and H as the endpoints. We have F, and we have G. Now, this doesn't necessarily mean it's drawn accurately, okay? With each part of the ratio, we're going to put a multiple of an x because we want to find that. So EF is going to be 5x, FG is going to be 3x, and GH is going to be 2x. We know that this whole segment is 30. So using segment addition, those three parts together equal 30. So 5x plus 3x plus 2x is equal to 30. So we get 10x equals 30, x is 3. Once you know x is 3, we can substitute. So 5 times 3 is 15, 3 times 3 is 9, 2 times 3 is 6. Which point of these is going to be an endpoint? So if I keep looking down the line and I say f is the midpoint, before f has a length of 15, after f has 9 plus 6, which is 15, which means f is the midpoint. Two more vocab terms then. An angle bisector. So an angle bisector is a ray that divides an angle into two congruent angles. So if we have an angle here, our ray is going to go in the middle of our angle and bisect into two congruent parts. If we have an angle trisector, then that's going to divide an angle into three congruent parts. So we would have two rays that are serving as trisectors. So we would have one here and one here. And those three angles are now congruent. So number 10, ray ES bisects angle WEB. Label and identify what is true. So if ES is an angle bisector, it's going to divide our angle into two congruent parts. So we have the same kind of arcs inside them, and then we can say angle WES is congruent to angle BES. Okay, now WS and BS could switch where they are, but E has to be in the middle because E is the vertex of our angle. So make sure you are being careful when you name your angles. In number 11, MAK is congruent to KAT, which is congruent to TAR. So what is true? So if those three angles are congruent, that means that these rays have to be angle trisectors. So we would say ray AK and ray AT are angle trisectors. In number 12, PR and PS trisect QPT. So all three of these angles are congruent. In part A, if PQR, where I put that blue dot, is 15 degrees, 18 minutes, and 32 seconds, find QPT. So QPT is the whole angle. So to get from QRT to QPT, we need to multiply by 3. So we're going to take that angle and we are going to multiply by 3. So each number by 3, that gets us 45 degrees, 54 minutes, and 96 seconds. Remember, anytime we're over 60, we need to reduce. So we're going to take one of those 60 of those seconds and turn it into 1 minute. So we have 45 degrees, 55 minutes, and 36 seconds. In B, we have QPT, and we want to find SPT. So this time, we know the whole angle, and we want to get to a smaller angle. So this time, we are going to divide by 3. So we're going to take 102 degrees, 48 minutes, and 24 seconds, and we're going to divide each of those by 3. So when we do that, 102 divided by 3 is 34 degrees, 48 divided by 3 is 16 minutes, and 24 divided by 3 is 8 seconds. In part C, it's a little bit tricky. If QPT is 63 degrees and 39 minutes, find SPQ. So SPQ, if we go back up and look at our angle, is actually 2 of those pieces. So what we want to do is we want to divide our angle into 3 parts and then multiply by the 2 parts that we are looking at. So what we're going to do is we are going to take 63 degrees, 39 minutes, we're going to divide by 3, and then we're going to multiply that answer by 2. So 2 times when we divide by 3, 63 divided by 3 is 21 degrees. 39 divided by 3 is 13 minutes. And then we multiply by 2, we get 42 degrees and 26 minutes.